today's lesson is going to be, and yes, even though it's very basic on what we have to write down and kind of go through, it can kind of get a little tricky as we go through the actual examples. Well, some of them. We'll be alright though. Either way, we'll get to that in class. But yeah, let's talk about this stuff. Let's go through this. Let's see what it is. We'll be really quick. So we have two theorems that we're going over: the radius tangency theorem and the exterior tangency theorem. All right. So a tangent, we've kind of already talked about that before. Um, Another word we kind of use also when we talk about not just trigonometry like we did before, like we talk about tangent, right? Like the tangent of a triangle, whatever. Either way, but it's also kind of circles, right? Trigonometry is actually based off circles, based off triangles. It's too much. Never mind. All right. Let's just kind of get into this instead. So what we're looking at here is we have a circle C, because again C is the center, and we have this line that's skimming it, right? So this is actually the tangent line. This is a line that's tangent to the circle, because if a line is tangent to a circle, right? So again, this tangent line that we're looking at happens to be this one. Then it is perpendicular to the point of tangency. Perpendicular to the point of tangency. So what's going on here? All right, so the tangent line we were looking at is this one right here. Because the definition of a tangent line basically is a line that touches a circle at one point, which really is right here. That point that it creates, the point that it lines up at. So that point that it hits, this is the point of tangency is what it's looking at. All right. Because all that means is this is the point where the circle and this line intersect, right? So a tangent line intersects it. If there happens to be a radius, all right, this is our radius. If our radius tangency, then what happens is it creates this right angle. That makes it perpendicular. All right, that's it. So it's going to be really useful. It's going to help us set up like right triangles and all these things we're looking at. But if a tangent line hits this point, it creates at the radius, it creates a right angle. So no matter where you go, and you're going to see that later too. All right. So a tangent line intersects with the radius at a 90-degree angle of a circle. Okay. The exterior tangency theorem. So this one is pretty straightforward. The idea is if two segments from the same exterior, right? So it's the exterior. Write this. Two segments from the same exterior point. So in this case, this is our point T that we're looking at. Are tangent to a circle. So again, these go here and they skim off this one point. Then those two are actually congruent. So what this means and what this is saying is that if you have these two lines that hit this point of tangency, right? This point right there, that point right there. If these two lines skim, come from the same point on the outside, which is point T, and they hit a point of tangency, then they are congruent. They are the same length, the same distance, same size, whatever you want to say. So really what's happening here is TR is congruent to TS. That's it. Alright, so a few things that are really helpful. Either we create perpendiculars from the radius and the tangent line, or if two tangent lines meet up on the outside, they're congruent themselves. I guess just real quick too, just remember, right, kind of what we set up here. Just note that there's always going to be these right angles from the radius to a tangent line that we'll see right there too. Alright. We'll talk about the rest of it in class. We'll go over the review, go over the notes. There you go.